All right, let's take a look at this conditional probability problem. You might not know it is when you first watch it, but when you first look at this, there could be all kinds of probability going on. But when you take a look at the first question relating to this, probability that a randomly chosen female has pierced ears, then you realize, right, oh, I'm being told one characteristic and asked about another. That's a condition. You're not just being asked, hey, female and pierced. That would just be an intersection of sets. And there's a big hint. In other words, what is the conditional probability that a randomly chosen student has pierced ears, given that this student is female? Okay, and we have the note that we're just using not M to represent female, uh, basically just to be a simplifier instead of M and F for two genders and, pierced ears P and not pierced ears N, right? We're just doing this and not this for both traits, having pierced or not pierced ears, being male or being female. So what do we want to do here when we're in this kind of scenario, when we're asked for representing conditional probability? It's really a matter of matching things to the general template you should have in your head. You should always be aware that you should be thinking about probability of A given B. Remember, the given is afterwards. The probability of A given B is going to be equal to the probability of the intersection, right? The intersection of A with B is inside B. That's the amount of A that's inside B, divided by the size of B, right? So it's like, it doesn't really matter how much A and B there are. If you're looking at B and half the size of B is overlapped with A, then if you know B is true, then the probability of A is 1/2. It doesn't matter what size A and B are in the whole universal set. It matters what their overlap is in comparison with the condition you've been given. That's the best way to orient yourself. That's the best way to get these problems done. The condition comes after. The condition is the bottom of the fraction. In other words, what is the conditional probability that a randomly chosen student has pierced ears, given that this student is female, right? Given that the student is female, right? So right there, we know that our conditional probability is going to end with given that the student is female, which we're calling not male, just for a convenience of E and not E, M and not M. So we're done, right? I mean, only one of these options has not M, so unless the item writer messed up terribly, that's the answer. We should think it through just in case there were multiple choices with not M. So that a randomly chosen student has pierced ears. So we're wondering about, hey, what's the probability? That's the event we're looking for, pierced ears. What's the chance of pierced ears given female? All right, and if we needed to do numbers, we would look at the intersection, look at the condition, and plug those numbers in from the table above, and we'd get a number. But in this case, we weren't asked for a number. Now, just so you know, the most dangerous and most common mistake is to reverse, right? To reverse the E and the M. Sometimes people, right? This case, you were given you read the sentence and, the question was first, the condition was last, and then, oh, it just goes in that way. First thing first, second thing second. No, you've got to make sure you're reading the sentences carefully. This is actually the most common wrong answer. I'll strike it through in red. Be careful. Make sure the given goes where the given needs to be, which is the end. Why? I don't know. Because it's the bottom of the fraction. Maybe that's why they invented the vertical line notation. shorthand to remind them you've got to divide by the B? That's my thinking. All right, let's move on to the second part of the question, where what's the probability of, okay, is this conditional? Is it intersection? What's going on? What is the probability that a randomly chosen student, oh, I've just got a randomly chosen student. That's like, that's right, just a randomly chosen student is a non-pierced male, non-pierced male. So, well, first of all, I can strike out this and let's see, non-pierced. So I can, oh, this has not M, right? This is male, right? So it's either the first or the third, right? I got rid of all the not M's because I'm asking about male and not, oh, okay. So now I'm stuck with, I have to decide whether it's this or this. Both of them have non-pierced and male as their parts. But this is not a conditional question. This is just given a student, what's the chance of a non-pierced male, right? Non-pierced there, male there, right? It's the intersection of non-pierced and male that we're interested in. Intersection. So this one is the correct answer. And that one isn't. That's the conditional probability, remember? That would read as male being the given. So that would be, what's the probability that a randomly chosen male does not have pierced ears? You hear that? Even though I mentioned the condition first, I kind of wanted to get that over with. It was last in the symbology. What's the chance that a randomly chosen male, aha, male is the condition, does not have pierced ears? Oh, that's the question. Versus, hey, random student, hey, are they a non-pierced male? What's the chance? Well, it looks like 144 out of 500. All right. The next part of the question is a bit different. Here we're starting with the symbols and we're being asked what the words are. There are two approaches. You could just write the symbols out for each one of these and then see what matches. Or you could carefully translate the given symbols into words. I'll actually do both just to make sure you get a lot of good practice. But it's a little faster, but you got to work slower to convert the given symbols into the proper words because you kind of have to go through an intermediate step. What you really want to be thinking about is the fact, you can say this any way you want. What's the chance of something given something, or given randomly selected something, what's the chance of whatever? So I'm not even looking at the multiple choice options. What I want to know is, right, this is asking me what's the probability of not pierced, right? That's the first thing. That's the question. That's the event. And the second part, as I've said many times, the second part is the given. So that's the way I'll put it. Given. And then since we're using not M as just our symbols for female, right? Now we know we have to look for the English that corresponds to asking about ears not pierced, giving the fact that the student is a female. Randomly chosen female, okay, that's good. Randomly chosen student, randomly chosen male, randomly chosen non-pierced. This is the only one that has the capacity to be the answer. Let's just double check, right? Is it actually asking the probability of being not pierced? Does not have pierced ears. right? So we get a perfect match here, right? It's not pierced ears is the question, and then randomly chosen female, right? You've chosen a female that's given to you. You've chosen a female. What's the chance that they're not pierced? And again, right, we could figure out the numbers. A randomly chosen female does not have pierced ears, so the randomly chosen, right? So we could do the numbers if we wanted to. We haven't been asked to, so don't. Now, as I promised, I said that I would do a little extra training and I'd talk to you about going the other way. Might be slower, right? In this one, we kind of got lucky. Once we knew the English, only one of them had given female. So we were done. We didn't have to deal with two remaining options like we did in the previous part. All right, randomly chosen male does not have pierced ears. It's not a big deal, right? Randomly chosen male means that's the given. So this is just not E given male. Sorry, my E looks like a B. That's a little weird. A randomly chosen student is a non-pierced female. So this is kind of cute. I'm going to move it down here, right? You're asking what's the probability of a non-pierced female given they're a student. But there's only students here. So given a student is just given somebody's in the universal set and everything's in the universal set. So this isn't even conditional. Just what's the probability of non-pierced, sorry, not E, and, which is the intersection symbol, female, not M. That's the intersection of the two. Remember, number 3 is about the conditional probability, not the intersection. And the final one, a randomly chosen non-pierced student. Oh, that would be the one most likely to fool you because it does have not pierced. It does have a not E in it. Wait, am I about to make the mistake? Yes, I am. You're being asked the probability of being female, but you are given that you're a non-pierced student, right? Given you're not pierced, that means you're one of these 176 people. And the question is, what's the chance you're not M, right? That'd be 36, the 32 over 176, right? That's a very different question than the one we're being asked here. That's the flip question, right? This is, what's the chance of being without piercings if you are a female? That's a very different probability. In fact, one of them involves a row and the other involves a column. That relates back to row and column probabilities much earlier in the book. They didn't call it conditional probability, but it actually was. And finally, we've got the last part of the question. This one finally asks, hey, what's the probability of this? We're no longer converting between symbols and sentences, but we're actually simply figuring something out. What is the probability of not having pierced ears given that the student is female, right? Again, maybe I should write that out in pseudo language, or maybe I just need to use my symbol knowledge finally, right? My symbolic knowledge tells me that I simply should take the probability of the intersection, right? Conditional probability is always the intersection, the and, divided by the condition. Intersection is easy. That means you've got both properties. And the condition should be either a row or a column. Not M. right? So here we go, right? I'm interested in the intersection. I want the probability. I want the probability of intersection, not E. That means not pierced. So that's this, not pierced over here. And not male, right? That means and female, right? Females are all here. So not pierced and female is there's 32 people who are not pierced and female. And then our condition was female, right? So that's out of the whole row of females. Conditional probability, right? Given female, oh, I don't even need to think about my male row. I might as well just knock it off the table because I'm given a female. So all I care about is the female row. That's how it relates to row and column probabilities earlier in the book, right? If I was interested in knowing, hey, what's the comparative rate of not having piercings, comparing males and females, well, then I'd want to go ahead and figure out the percentages, right? I'd want to divide each one of these by 180, and I'd want to divide each one of these by 320, and I would get the decimals. Like I'll do the quick work here. The males, given a male, the not pierced is 80%. And given female, it's 10% not in this particular group of students. So that compares the rate of piercings instead of just comparing the amount. 144 compared to 32, that looks like 4 or 5 times as much. But actually, the rate of piercing is 8 times as much. Sorry, non-piercing is 8 times as much for males as females, the actual rate. That's just a little bonus. I mean, once we were done going intersection over condition, then we were done here. And I just want to point out, why was a 500 on the bottom? That would have been the intersection over any student. So the unconditional probability of not pierced and female. That wasn't the question. All right, what about the 32 over 176? That looks like it would be female given, wait, that would be given not pierced, right? The bottom of the fraction is always the given. Given not pierced, what's the chance of a female, right? That's the E and the M reversed over here would give us that answer. The 288 over 320, I don't exactly, I think that might be the not applied too many times. I think 288 plus 32 is 320. So I think that's applying the not too much. Or maybe that's just, right, just misreading, right? That's the chance that a female, right? We're still given 320, so we're given a female. The female is pierced. So that's losing a knot, not an extra knot, but losing a knot, right? If that was gone, then that first option would be the answer, right? Notice how in multiple choice selections, the wrong answers are often plausible or involve a somewhat predictable error. That's not a mistake. That's exactly how the statistics exam is written. And more importantly, that's exactly how praxis exams are written. So be aware, you really have to know your answer. You can't just be in the vicinity of the answer because one of those wrong answers is going to be there. These two are both fairly common mistakes. This one is rarer. The first one is rarer, but it's possible. Maybe the reader got confused by too many knots. Anyway, there's some test taking advice along with 4 examples of the kinds of questions that involve conditional probability given one of these two-way contingency tables.